Welcome back. So I decided to erase my work and start over, just to double check. And I have the exact same points. There was nothing wrong with anything I did. I thought maybe, did I write down the wrong coordinate? Maybe my eyes were looking at the line of reflection that's already graphed. No, that wasn't it. So we had the right starting points for A, B, C. Of course, on a 90-degree rotation, about going clockwise about the origin, right? Your X and Y switch, and the second one becomes the opposite. And that's because that's how the signs change as you go clockwise around the coordinate plane. If we were going counterclockwise, it would be the reverse. It would be not the X not the second one that became negative, but the first one. Right? So, and I shouldn't say negative, that was negated, right? Because if it's already negative, it becomes positive. Right? And so we would just switch our X and Y, right? And then make the all those new Y coordinates negative. Right? So we did that. So we're on the last thing. So either I just put a point in the wrong spot, or I just kind of undershot my line and it made my triangle look like it was graphed someplace else. But that is the correct triangle. I don't remember what I did because I erased it. And it's not important because now we have it fixed. All right, so now we're going to reflect over the line y equals x. And this one's not so easy with a rule. The one thing we can say, though, is it's a vertical line, so your y coordinates aren't going to change. So that means, and that'll be true anytime you reflect over a vertical line. This is going to be -1, -4, -2. No problem there. However, the x coordinates, because that's not the y-axis or the x-axis or any of the ones that have a rule to it that are based on the origin, we're going to have to count. Okay? I'll put a little makeshift rule up there just to fill in our spot, I guess. All right, so notice from our line of reflection, notice that A prime is 2 to the left. Right? So it's going to have to move 2 to the right just to get to the line of reflection, and then it's going to have to move another 2. Right? So A and B here, they're going to move 4 to the right. C is 1 to the right already. So it's going to have to go 1 to the left just to get to the line of reflection. And then it's going to have to go 1 more, right, to be on the opposite side. So we're going to subtract 2. Right? And all I'm doing is I'm just counting the distances and then doubling them. And it's based on the direction. Is it going to go to the right or to the left? And it just depends on what side of the line of reflection you're in. Right? So if we added 4 and then this 4 here is just for A and B, and then this one here is for C. Right? So if we add 4 to the x coordinates, this becomes 3 and 3. If we subtract 2, that becomes 0. So now let's see if that looks correct. We have 3, 1, 2, 3, -1. Right here is A double prime. And then 3, -4. Of course, x coordinates aren't going to change on that reflection. Or the y coordinates, excuse me, aren't going to change on that reflection. That would be B double prime. And then 0, 0, -2. Right here is going to be C double prime. Right? So notice they're all moved the same direction. And they're same distance from that line of reflection as from the image to the original to the image. Right? And, oops, no, I don't want to clone it. So that is 2. Notice I undershot my line again. Just a little bit when I'm graphing my point. It's located right here, but sometimes the points just don't want to go where you want them to be. Right? So our final figure, let's connect our points, is going to be right here. There we go. So even on a tricky one, a matrix does help out. And it helps out even more when we don't have reflect over something that's not rule-based. So here was 3, -1. B double prime is 3, -4. And C double prime is 0, -2. Let's do the next one. I already put up the matrix, little matrices, and I often do that, just so I already have it up there and I can save a little bit of time. So go ahead and write those down. We have the exact same starting triangle. Our first transformation is to reflect in y equals x. When we reflect over or in y equals x, remember our x and y coordinates switch. So let's just do that. That tells us what our rule is going to be. Then we're going to translate with vector -1, -3. Right? So that just means we're going to go all the x coordinates. we're going to subtract 1 from all the x coordinates and subtract negative 3 from all the y coordinates. In other words, our figure is going 1 to the left and 3 down. All right, so now we'll get our points. So here on the first one, we just got to switch the x and y. So we're going to have negative 1, 1, negative 1, 4, and 2, 2. And that point doesn't change because C is on the line of reflection. All right, so negative 1, 1 is right here. That's going to be A prime. And then negative 1, 4, 2, 3, 4 right there. That'll be B prime, and that's still C prime right there. And so here is, oops, and I undershot made my line looking all weird here. Let's try drawing a straight line again. Right. That line looks okay. Let's see if we can get there. Let's try that one first. Okay, that looks good. And that one looks good. All right, so notice that it does look like a reflection over that line. Right, and so now we just have to translate. Right, so we're just going to subtract 1 from all the x's. Right, so this is now going to be negative 2, 1. And subtract 3 from all the y's. So negative 2 and positive 1 and negative 1. All right, so let's take a look what this looks like. All right, so we have negative 2, negative 2. So that's going to be right here. Will be A double prime. And then negative 2, 1. So that's going to be right here. Will be B double prime. And then C is at 1, negative 1, right where A is. And that's going to give us, A is so far away from the point here. I almost went to the letter rather than the point. And there we go. So notice that A prime, B prime, C prime, and A double prime, B double prime, C double prime, right? They're facing the same direction because it's a translation. They've just moved to a new position. And so our final coordinates on that one were negative 2, negative 2, negative 2, 1, and 1, negative 1, and we're done. Right, let's go on to the next one. All right, so here we're going to be, we're only going to be moving a point, a single point. That's nice. We don't have as many things to move. Just one thing, and that's point negative 3, 5. And I already graphed the line of reflection. I believe it's on yours as well. So 1, 2, 3, and then 5. 1, 2, 3, 4, 5. All right, so that's, why did I put a prime there? That's A. Right, so for A, we are translating. Right, it's in coordinate notation there. xy becomes x minus 2, y plus 5. So we're going to subtract 2 from all the x's, add 5 to all the y's. Right? So that means that we're moving 2 to the left and 5 up, which we're just going to barely fit in there. All right, so when we, oops, sorry, I didn't, again, my shadow was blocking me. I didn't realize I already wrote the vector down. And you have it already in your notes, so you're probably looking at me like, what? You didn't add them? So negative 5 and 10. So that's where A prime will be. I already had the vector written down, silly me. So negative 5, so we're going to be at right here. And then at 10, this is already 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like I said, just barely fits. So there's A prime. And then we're reflecting over the line y equals 4. So we have a horizontal line. So we know when we reflect over a horizontal line, so I'll just put a little arrow in here, that, I'll put it in black, that are, and that is in there for good. There we go. This time, our x coordinate won't change. So if you reflect over a vertical, your y coordinate won't change. If you reflect over horizontal, your x coordinate won't change, but the y will. All right, so notice that we are 5 away. Actually, I didn't mean to write that there. What I meant to write is just x, right? Because that's not going to change. Where that negative 5 is going to go is in the next spot. All Right, so we're 5 away, right, from the line of reflection. We're above it, so we're going to have to subtract 5 just to get to the line of reflection. And if we subtract 10, we'll be on the other side. So that means that our point is going to be -5. That won't change. And 0. Right, so here is, no, one little thing. Didn't really change anything, because I knew where the point was, where that line was supposed to be at. It wasn't at, oh, it's at y equals 4. I'm sorry, I thought it was at y equals 5. That's y equals 4. You can tell I'm a little tired today. So we're not 5 away. I'm sticking out at 5. 1, 2, 3, 4, 5. We're at 6 away. So I apologize. We're not going to be subtracting 10. We're going to be subtracting 12. That's 2 mess-ups. Well, there were a couple of minor messes up in this nearby, but that was 2 mess-ups. So this should be -12. So we're going to be at -2. I know what I was looking at, but for some reason I glanced up there, and I don't know why. I mean, it even says y equals 4. Why I have y equals 5 in my head? I don't know. Maybe because that point's at -5. I got 5 in my head. Right? So instead of being there, it's going to be right here, right, at -5, -2. Right? And that is a double prime. Right? So here it was at -5, 10. And then we reflected, right? So we're 6 away, so we're still going to be 6 away. All right, so now let's take a look at the last one that's on this page. All right, so let's graph that point, same point. And that is 3, -5, so -3, 5. There's A, where we are translating according to the vector. xy becomes x plus 3, x plus 2, means we're going to add 3 to the x's, 2 to the y's. And then we're going to be reflecting over the line y equals x. Remember, when we reflect over the line y equals x, we simply switch the x and the y. Right? So A prime is going to be 0, 7. Right? So that's going to be 1, 2, 3, 4, 5, 6, 7, right there. And that's A prime. Right? And then if we switch the x and the y, that's just going to be 7, 0. So A double prime is just going to be 1, 2, 3, 4, 5, 6, 7, right there. And you can see that that is a reflection over that line. If we were to connect those 2 points, they would be perpendicular to our line of reflection. Right? So using the matrices will really help you keep everything organized. I'm going to do a couple more. So figuring out composite transformations, we're going to go the other way now. So you start with the most obvious type of transformation. Focus on matching orientation first, then match the image position, and always graph intermediate figures when determining composite transformations. Right? It's a lot easier to get, if the figures aren't in the same location, it's easy to translate them to get them in the same location. But if they're not facing the same way, right, and you try to get them in the same location, then it becomes difficult, a little bit more difficult to get them to face the same way. Right? So sometimes it's easier if you start with focusing on matching that orientation, then deal with position. All right, so let's look at this one. All right, so if we were to do, so let's look at number 1. If we were to be completely correct about this and finding our transformation, we would actually want to use a compass. But on the little coordinate plane and having to deal with a whole lot of lines there, it will be much more difficult. So we're not going to do a compass. Let's first of all figure out our transformations. The first one, I think, is easy. This one is easier because they've got the first, the second, and they have the pre-image, the first image, and the second image graphed. It's harder if that first image is not graphed, trying to figure out how to get from one to the other. Right? But because they gave us the first image, that makes it a lot easier. Right? So notice this is a reflection, right? We're mirror images. This is not the x-axis though, right? Because figure here is only 1 away. Figure here is 2 away. Right? So the x-axis is not in the middle. We need a point that's in the middle. And actually, I'm going to use a line tool to graph that point, or that line. So a line that's in the middle, right? So notice there's 3 spaces in between those two. It's got to be A. All right, so you're not cooperating. Where's my line tool? It's not what I asked for. I should have locked this one. Let's see if I'm going to get a line tool. No. I don't know why I don't have a line tool here. Let's try one more and then I'm going to graph it myself. There we go. All right, well now I have to move it all back first. Silly line tool. All right, now let's get a line again. Okay, now let's try. All right, so halfway between, half of 3. Oh my gosh. I knew I should have paused the tape, started a new one, because I would have deleted this part. Fine. We don't need you. We will just graph. I will just do it myself. I don't need you, silly line tool. All right, there's our line of reflection. Right? That would be halfway between. Where's that line located? At at y equals 1/2. Line tool's got me all frustrated. Y equals 1/2. All right, horizontal line, y equals. Right, has a y-intercept. All right, so that's our first transformation, and we always need to make sure we write it down completely. So the first thing we did is we reflect over the line y equals 1/2. All right, so now how did we get from the first image to the second image? All right, well, we can see it's not facing, get rid of that thing, it's not facing the same way. It's not a mirror image, it's not facing the same way, so it's got to be a rotation. So if we wanted to be perfectly accurate in the steps, to find that point of rotation, we would connect all our corresponding points, and we would do perpendicular bisector for each one of them, and where those bisectors intersected, that would be our point of reflection. Now if we try to do that, this is going to be so busy in here that we're not going to be able to tell the difference between one line and the other. Right? So my suggestion is we're going to do the same thing. We're going to do perpendicular bisectors, but we're going to use the graph to help us rather than the compass, because we can graph a perpendicular line. And second of all, we're going to do one line at a time. We'll do one perpendicular bisector, right? And we'll use that to check and see, right? Is that the right point of rotation or not? Right? And if not, we'll keep going. We'll use another perpendicular bisector and see where those two intersect. Right? Will that be the right one? Now my suggestion is to use the easiest ones, like B prime and B double prime. Look how close they are. Right? And since my line tool is being a pain in the butt, I'll just graph that myself. All right, so notice there that that line that connects them, that has a slope of 1. So the perpendicular line, so the slope of B prime, B double prime is equal to 1. The perpendicular line would be -1. So let's graph that and see if that helps us figure out the point of rotation. If that doesn't help us, and that is not well graphed, can I move it over a little bit? Here we go. Then we'll do the same thing with another line, another pair of corresponding points, and see where the two of them intersect. Right? In actuality, it's where all 4 of them will intersect, but there's no room for all of that. All right, so if that's going to be where our if it happens to be on this line that all of our perpendicular bisectors intersect, right, then it's going to be somewhere like maybe here. Let's see if that point works out. Right? We just have to make sure, right, we're the same distance away, and we've just switched the x and the y. It's good for b and b prime. Notice here, this is 1. If we connect those two, right? Notice we got a 90-degree angle, right? Those are horizontal and vertical are switched. So that looks good so far, but will it work with more points? Let's try A and see if it works with A. Let's get rid of this. So we know it's okay for B. Is it okay for A? All right, so if I do that, there's that one, right? And there's A. We still have 90 degrees. So far, so good. It worked for 2 points. Sometimes you luck out, and you can get it right away. Let's see if it works for C. With that being the point of rotation, that we're the same distance and the same direction. Oh, by the way, I didn't count, but 1, 2, 3, 4, 5, 6 to the left. 1, 2, 3, 4, 5, 6 up. All right, let's try C and C prime. All right, so C is probably going to be the one that messes up, or if it's not the right, let's see if it works out. All right, so C, notice that one, from that would be, so we'll count 1, 2, 3 this way, and 2 this way from that line. Are they flipped? All right, let's find out. So we've got 1, 2 here, and 1, 2, 3 there. They're flipped. Right? So 3, 2, 2, 3. Right? And so we just use that first perpendicular bisector to check and see, could it be located on that perpendicular bisector? Right? If that wasn't the right point, then we would see where the 2 perpendicular bisectors intersected. Right? It's still going to be a point on that line, but maybe not that point. But so far, so good. Right? Everything has been a 90 degrees over that, because on a 90-degree rotation, the horizontal and vertical switch. The last point that could mess us up is D. It's got to work for everybody. I lost part of my line, but that's okay. So this is the hardest thing, is figuring out a point of rotation when it's not the origin. Now, how did I know it's not the origin? Look at your distances. B here is B prime is 1, 2, 3 down, and B double prime is 1 to the right and 2 down. That's not horizontal and vertical switching, so it was not around the origin. So the hardest transformation of all to figure out is the point of rotation when it's not the origin. All right, so let's check the last pair of points, and that is D prime and D double prime. All right, and so now I just count horizontal and vertical. 1, 2, and then 1, 2, 3, 4, 5. If we got 2, 5, we got it. 1, 2, and then 1, 2, 3, 4, 5. I don't usually get it in the first try, and I did not do this one ahead of time. That's it. All right, that's the right point of rotation. So you see that everything, the horizontal and vertical distances from every pair of corresponding points is just switched. That's the right point of rotation. So now let's finish writing this. So it's going to be a rotation, and it's 90 degrees. Right, and so now which way are we going? Right? Notice that we're going, I should probably, I'll use green again. We're going this direction, right? So B prime is going to B double prime there. Right? And so we're rotating clockwise, right? We're going with the clock. Right, clockwise. So rotation 90 degrees clockwise, and this was about That point there is 1, and then 1, negative 3. So that is the toughest transformation to figure out, that rotation where it's not the origin and not a point on the figure. Unlike this, on the second, number 7 there, the point of rotation is on the figure. It's really easy to figure out. All right, so that one took us a little time, but it was good because you got to see a really tough problem. What if I can get rid of that since it was of no use to me whatsoever? Nope. I'll just be stuck with that. Ha, there we go, cut. All right, let's do this one over here. All right, so we have to make sure we go in order. All right, so we have to go from the, this one is the pre-image. First image. And second image. All right, so notice on that first one, it is a, so we're going, notice this line here maps to this line here. All right, that's a 90-degree rotation. And we're rotating. You can write this 2 ways. About. You can either say A, or you can write the point, which is -2, -1. Either is fine. That was the first thing we did. All right, so now notice that A prime, B prime, C prime, and A double prime, B double prime, C double prime, they're facing in the exact same direction. So that's a translation. So we translated. And all we got to do is figure out how far. X, Y goes to. Right, so we are moving to the right. Right, and just going to match corresponding points. I'll match, I'm going to use a different color. I'll match B prime and B double prime. Right, so we've moved 1, 2, 3, 4, 5. Right, and the other thing you can do is you can just, if it's not easy to count, you can just add. Right, so this was -2, 2. And this point here is at 3, 0. Right? So what would you have to add to -2 to get to 3? You'd have to add 5. Right? So this is x plus 5. And what would you have to add to 2 to get to 0? Or you can count. You'd have to add -2. That's what you have to add to y. Right? So that's our translation. And then if we were doing the vector, of course, it would go diagonal. Right? And that's all there is to this one. The second one was easier than the first one. A lot easier. And actually, in previous years, I've done perpendicular, where all the perpendicular bisectors intersected on that rotation where it's not the origin. For me, it's okay because I can make all the lines different colors. For you, it would be a nightmare. So this was my way to teach it to you with a little, with an easier technique and a little trial and error. Let's finish up the last of these. I did not think that this is a whiteboard practice for you. All right, so here it is a single transformation. All right, and I've given you a not a hint on what the transformations are, but a hint on how to write them. All right, so remember for the translation, you can use the coordinate notation and just follow that to notate it correctly. Remember for rotation, you got to tell me degrees, direction, and about what point. And then for reflection, you got to tell me the line of reflection. All right, let's go past your whiteboard practice to the last thing. All right, so now this is 2 transformations, and they didn't give us the intermediate one. In the grids below, determine the series of transformations that was performed on each pre-image to obtain each image. Be specific. For example, if the pre-image was rotated, you must include degrees and direction. If the pre-image was reflected, you must say over which axis and or explain the movement between quadrants. Right? So we need to figure out 2 transformations that will map our points. Now, in the beginning of doing this, I said do the most obvious ones first. The most obvious thing is this was definitely, on the first one, rotated. Right? They are not mirror images, and they are not facing the same way. Now, you might have thought reflection, and possibly you could do this. You might be able to do this actually in one movement you can do it as one movement as a reflection, but it's not something you're used to reflecting over. I'll show you if you wanted to do it in one movement after we do it in 2, right? Because it asked us to do it in 2. So the first thing I would do is get it facing the same direction, which means you're going to have to rotate it, right? And notice it's moved 2 quadrants. I'm almost contemplating actually, I take it back. I think I wanted to do a reflection, not a rotation. And you know why? Because when I look at the rotation, so this vertical going to this horizontal, that's 90 degrees. And notice it's moved 2 quadrants. So this was not done as a rotation. This was done as a diagonal reflection, right? So this is definitely a reflection over a diagonal line because we moved 2 quadrants, yet we're not, so it's not the x and y's are switched, right? Or the x and y's aren't negated, they actually are switched, they're not. So if this were 180, this figure over here should look like this over here. And that's going to have to be on the, like that over there, right? And it doesn't. So that's not a rotation, that's a reflection. I was almost fooled. All right, so our line of reflection should be a diagonal line. I give up on using my line tool. So I will draw my crooked line. My very crooked line. This was all board, not me making that boo-boo there. All right, so let's choose this line. Let's see if I can get the line tool just to go over that, because that's really crooked. Yeah, there we go. All right, so we're going to reflect over that line. That line is y equals negative x. Let's see where that gets us. All right, so our points here, we've got, this is -2, -1. This is, actually, let's write this as a little matrix rather than trying to get that all in there. All right, so we've got -2, -1. B is at 1, 2, 3, 4. -4, 1, 2, 3, 4, 5. -4, -5. And then C is at -2, 1, 2, 3, 4, 5. -2, -5. All right, so if we reflect over y equals x, y equals negative x, excuse me, then they're going to switch and negate. So this is going to be set of xy, negative y, negative x. All right, and if we do that, we'll continue writing over here, then that would give us 1, 2, and 5, 4, and 5, 2. Now sometimes you may try something and it doesn't work out. But I think a diagonal reflection is going to be a little better than trying to do a rotation. And I think that's what was done. So 1, 2 would put that right here. That would be A prime, B prime, C prime. 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. And then 5, 2. So right there, but at 2. Ah, that was a very wise choice, wasn't it? Because you notice we're now facing the same direction. Right? So the first transformation was reflect over y equals negative x, right? Because we want to go across. If it had been a rotation, then at 180 degrees, because we've moved 2 quadrants, then whatever was vertical on the pre-image should be vertical on the image. Oh, you know, I did make a little tiny error. I accidentally switched who's A and who's B and who's C. I mean, who's the pre-image and who's the image. I just realized that. I'm looking at the pre-image thinking that's the image. However, we'll just flip those and that will still be the same. All right, so A, B, C, it's still the right transformation, it just goes the other way. So A is at 0, 1. B is at 1, 2, 3, 4, 3. And C is at 1, 3. And then if we reflect over y equals negative x, right? They're still going to switch and negate. So that would be negative y, negative x. And that's going to go to, let's get rid of this so we have some space. Maybe I should have made this 2 nearpods. Right, so that's going to be a prime, b prime, c prime. And so now that's going to be negative 1, 0. That's not going to change. And then negative 3, negative 4, and negative 3, negative 1. So that should be here, negative 1, 0, negative 3, negative 4, and negative 3, negative 1. And we have that, yeah. I like to go in the other way, actually, to the second image, back to the pre-image. We're supposed to go from the pre-image. I should have really right, so that's handy-dandy hip number 20. Write pre-image and image, so you don't accidentally reverse them, even though they're marked with prime symbols. So who are we missing? Negative 1, 0, negative 3, negative 4, and negative 3, negative 1. Yeah. Let's make sure that we wrote all the points down right. So, oh my gosh. Did I write down? Nope, 0, 1 is right. I thought I wrote down 1, 0, 0. So 0, 1, good. And then 1, 2, 3, 4, 3. And then, oops. You reverse those. You can tell I'm tired and I want to finish. 1, 2, 3, 4, 1. I don't know where I counted that from. And so we just need to change C prime. That's, I swear, my last little error here. Counting today. Ay, ay, ay. So now it's going to be negative 1, negative 4. And that seems to be a whole lot better. And you can now, here we go. The hazards of working on a large board. Sometimes you just can't see everything around you when you write down the wrong thing. Now we can see what to do, right? So we reflected over y equals negative x. Notice that all of our points just need to move in this direction. They're moving 1 to the left and 1 down. That's the second part. So we're going to translate. And xy becomes x minus 1, y minus 1. We're in the last problem. Holy cow. Oh, by the way, we could have done this as a single transformation. And here's the single transformation on that first one. Single transformation. We would have reflected the line right there. So if we reflected over y equals, that would be negative x minus 1. You can see that that would be a mirror image. But we need to do it in 2. The second one here, the last one. All right, so you've got, we have to do it in 2. Right? So you have a few different options here. If you could do it in 3, you could reflect over this way. Right? Oops. No, imagine that's a triangle there. And then reflect over another line and then translate. So, or we could rotate and then translate, or we could do, if we do the right rotate or reflection, we could also get it. We'll do it 2 ways, really, really quick, I promise. All right, so let's reflect it across the y-axis. This one, I off the top of my head, I can't figure out how to do it in 1. Actually, I can. We'll do it in 1 after this one. We'll just do 1 way and then how to do it in 1. Reflect across, but if you're told to do it in 2, you have to. But let's do it in 1 as well. Reflect over across the y-axis. All right, so that's going to change our coordinates. It's just going to be right over here, right? 1, 2, 3, 4. 1, 2, 3, 4. I'm not going to even write a matrix on this one because that's an easy reflection. All right, so there we go. All right, so there would be that 1 point, the A, oh, I did it again. All right, well, we'll still reflect over the y-axis, but it's this one. Why do I keep doing that? 1, 2, 3, 4. 1, 2. Maybe because I'm trying to go quickly. Because I don't like the tapes to be this long. All right, we reflected over the y-axis. There we go. Reflect the right figure. If we choose the right reflection, we can do it in one. And where's going to be our line? Right there. All right, so we can do this one as reflect across the y-axis and reflect across x equals, y equals -1. Right, and that will map our figure. This one will be right down here. Right? There are other ways to do this and other orderings to do this. You could have reflected over the x-axis, but then it gets kind of tricky to get that into the right location. Right? Or you could reflect it over y equals -1 and then reflect it over the y-axis. You could actually do this in one transformation. So let me show you where the one transformation would be. And that would be a rotation. So if you wanted to do it in one transformation, if you rotated, so here's our single transformation, and the last thing I'm going to say, if you rotate 180 degrees, and the direction doesn't matter, about, that is 0, -1, you can do it. You would map all of your points, right? If you rotate across that line. But we had to do it in 2, and there we did it in 2. Right? Woo, I'm sorry that this was so long. Maybe this should, I can't really make it 2 Nearpods because I had that weird break. The whiteboard practice is also in your notes, so you've got both whiteboard practices. But because this is a long Nearpod, you're going to get some extra points for watching me and watching me try to reflect and rotate in the wrong direction. But I hope you liked it anyway and you learned a lot. And thanks for watching. Bye for now.